What we're going to do before we talk about something called the quadratic formula is we're just going to quickly review how you find the roots of a quadratic equation. Remember, when you're finding the roots, you're actually looking for the x-intercepts, and that's why your equation is equal to 0. Anytime you have an equation equal to 0, you're finding the roots. So if we look at this, we need two numbers that multiply to negative, negative 18 and add to 7. Those two numbers are positive 9 and negative 2. And if I solve these, I get x is negative 9 and x is 2. That's pretty straightforward. In the second case, we need to use box method to try and factor this question. So we need two numbers that multiply to negative 72 and add to negative 1. Well, that's negative 9 and positive 8. So we have negative 9 and positive 8. And we divide each of these by 6, and now we're going to simplify. We divide by 3 here, and we're going to get negative 3 over 2. We divide by 2 here, and we're going to get 4 over 3. So our factors are 2x minus 3, 3x plus 4. That's still equal to 0. Now we equate each factor to 0, and we solve for x. So this left-hand side is going to give us an x-intercept of 3/2. The right side is going to give us an x-intercept of negative 4/3. So those are pretty standard. We've seen questions like that before. Now the next question says, is it possible to solve this quadratic equation by using one of the methods above? So either box method or just by inspecting it and looking at the two numbers that are here. If we look at this and we try to use box method, we need two numbers that multiply to 10 and add to negative 8. Well, we got 10 and 1, we got 5 and 2, so we can't. There are not two numbers that multiply to 10 and add to negative 8. So it's impossible to factor this, but we should still be able to find the x-intercepts of this equation. If you actually graphed it on your calculator, and we're going to do that quickly, we're going to look at 2x squared minus 8x plus 5. And if we look at the graph of this particular function, it does have two x-intercepts. So we should be able to calculate those x-intercepts algebraically. But at this point, all of the methods we know don't work. So we have to look at some new methods. We've learned how to complete the square. So we actually can complete the square on this particular question and find the x-intercepts. So the first thing we needed to do is we needed to factor a 2 out of our first two terms. Then you take half the middle term and you square it. So we're going to add 16 and subtract 16. Our squared factor is x minus 4 squared. When you move negative 16 outside the brackets, you have to times it by 2. So you get negative 32 plus 5, and that's still equal to 0. So you get 2 x minus 4 squared. Now negative 32, hold the phone. I really messed up here. I forgot to divide my value by 2 way up here at the beginning. We need to go back and fix this up. Sorry guys, I made a mistake. Up here, if we take negative 8 and divide it by 2, we get negative 4. Half of negative 4 is negative 2, and negative 2 squared is plus and minus 4. So we get 2x minus 2 squared. Now when you take negative 4 outside, negative 4 times 2 is negative 8 plus 5. So we get 2 x minus 2 squared. Now negative 8 plus 5 gives us negative 3. Now to start solving for x, the first thing we're going to do is we're going to add 3 to the other side. The next thing we're going to do is divide by 2. Now to get rid of this squared factor, we take the square root of the left side. And remember, when you take the square root of a value, you have to take the positive and negative square root. So we end up with x minus 2 equals plus or minus root 3 over 2. and to solve for x, we add 2 to the other side, and the two roots or two x-intercepts of our equation are 2 plus root 3 over 2 and 2 minus the square root of 3 over 2. So if you converted those to decimals and checked them on your calculator, they'd work out. So we can find the x-intercepts of a question by completing the square. Problem is this is a really long method. Lots of work, lots of possibility for error, all of that sort of stuff. So we're going to look at something called the quadratic formula. We're actually going to use completing the square with this general form equation, and we're going to complete the square on the general form equation. We're going to end up with the quadratic formula, and then we're going to use that quadratic formula to actually solve some problems. So first thing we do is we factor out our leading coefficient, which is a. We factor that out from our first two values, our x squared and our x. Now half of b over a is b over 2a. You divide that by 2. Then you need to square this. Well, if you square b, you get b squared. And if you square 2a, well, 2 squared is 4, and when you square a, you get a squared. So that's what we're going to add and subtract. We're going to add and subtract b squared minus or plus 4ac and minus b squared and 4ac. So now we get a. Half of our middle term is going to be x plus b over 2a squared. Because remember, half of the middle term is our squared factor. When we move this negative quantity outside, we need to times it by a. Well, if we times it by a, it cancels out one of the a's in our denominator. So what we end up with is we end up with b squared over 4a plus c equals 0. So now what we're going to do is we're going to take this portion and we're going to move it over to the right side. Because remember, we're going to try and use our completed the square form to form something called the quadratic formula. So if we add this, we get b squared over 4a, and if we subtract that, we get negative c. So now we got to divide by a. Well, if we divide by a in this first case, we've already got an a there. So when we divide by a, we get a second a. So that's going to make that b squared over 4a squared. When we divide c by a, we just get c over a. Now, we have to come up with a common denominator here, and our common denominator is going to be 4a squared. Now, I multiplied this by 4a, so I have to multiply the numerator by 4a, and I still have x plus b over 2a squared. Now, if I add these two things together, I get x plus b over 2a squared equals b squared minus 4ac all over 4a squared. Now, to get rid of this squared factor on the left side, I have to take the square root. So I square root this, and I take the positive and negative square root of that. Well, that leaves you with x plus b over 2a. This leaves us with plus or minus. If we look at the numerator, it's the square root of b squared minus 4ac. If we square root the denominator, square root of 4 is 2. Square root of a squared is just a. And the last thing that we do is we subtract b over 2a to the right side. So we get negative b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. We actually created it by using completing the square. Some of you are sitting there going, man, I'm never going to remember how to do that. You're right. The reason I showed you this is so that you know where this formula came from. We're going to use the quadratic formula in a second. At the top of the next page, we have the quadratic formula summarized in its exact form here. Am I ever going to ask you to complete the square and develop quadratic formula like I did here? No. But one of the things they want me to show you is how did we come up with quadratic formula. It's not just this magical formula that dropped out of the air and appeared. It actually has some mathematical significance. If you look at quadratic formula, it's based on a general form quadratic equation. So if I have ax squared plus bx plus c equals 0, and I actually have 2x squared plus 5x plus 2 equals 0, well, my a value is 2, my b value is 5, and my c value is 2. Those are the values I would substitute into my quadratic formula to try and get a solution. Now, we're going to do a couple examples using quadratic formula and to help illustrate how it works to help you find the x-intercepts. Now, it wants us to give our answers as exact values and as values as decimals to the nearest tenth. If we look at this first equation has an a value of 1, a b value of 2, and a c value of -1. Don't forget about that negative. So if we take x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, that's our quadratic formula. And if we start substituting in, we substitute 2 in for b, so that's going to give us -2 because we take the negative of b, plus or minus 2 squared minus 4 times 1 times -1, because that's our a and our c, times 2 over 1. So now I start simplifying things. 2 squared is 4, -4 times 1 is -4, and -4 times -1 is +4 all over 2. Now, this is going to give us x equals -2 plus or minus the square root of 8 all over 2. Now, you can simplify the square root of 8. Remember, the square root of 8 is the square root of 4 times the square root of 2, or 2 root 2. So this becomes -2 plus or minus 2 root 2 all over 2. Now you're going to see that these coefficients outside the radical, it's really important that they're outside the radical, are all 2. So I can divide them all by 2, and I end up with -1 plus or minus root 2 as being my values of x. And I have two values of x there. I have -1 plus root 2 and -1 minus root 2. They also want us to express these values to the nearest tenth. So if you take out your calculator and you go -1 plus the square root of 2, you get 0.4. And if you also go -1 minus the square root of 2, you get -2.4. So our two values are -2.4 and 0.4 as decimals. So that formula isn't too bad. If I know what a, b, and c are, I'm able to substitute them in and I'm able to find my x-intercepts. No matter what. Quadratic formula also will work with questions that could be factored, like these first two examples that we did today. Even though they're factorable, if you're having trouble factoring them, you could take your a, b, and c values from these equations and you could still get the x-intercepts for those particular equations. If we look at this third example, before we can do anything, we have to expand and we have to form a quadratic equation. We have to form something equal to 0 before we can get our a, b, and c value. So in this case, a is 4, b is -12, and c is -15. So if we plug this into our quadratic formula, we take the negative of b, so the negative of -12 is going to give us 12, plus or minus -12 squared minus 4 times a is 4, times c, which is -15, all over 2 times a, which is 4. So this gives us 12 plus or minus Negative 12 squared is 144. You need to be careful on your calculator. If you go negative 12 and square it, it's going to give you negative 144, and that's wrong. Whenever you square a negative value, you have to put it in brackets, and it gives you a positive answer of 144 here. If we take negative 4 times 4 is 16, and negative 16 times negative 15 is going to give us 240 all over 8. So this is 12 plus or minus 384 all over 8. Now, if I look at 384, I have to find a perfect square that divides evenly by 384. Well, it happens to be 64 and 6. So this ends up being 64 times 6, which works out to be 12 plus or minus the square root of 64 is 8, root 6 all over 8. Now, if we simplify this, we can actually divide all of these things by 4, the 12, the 8, and the 8. If I divide them by 4, I get 3 plus or minus 2 root 6 all over 2. And there are my two x-intercepts using quadratic formula. One of them is 3 plus 2 root 6 over 2. The other is 3 minus 2 root 6 over 2. Last example, and just like the previous video, you've seen a couple examples using quadratic formula. What you might want to do is stop the video, try doing this example using quadratic formula first on your own. Then play the video and see if you get the same solution. I'm going to continue on. I'm going to create the video, so if you want to stop it, go ahead. If not, if you want to watch, then we are going to write out our quadratic formula and get started with finding our x-intercepts. Remember, a in this case is negative 3, b is 4, and c is 1. So we get the negative of b will give us negative 4 plus or minus 4 squared minus 4 times a is negative 3 times c, which is 1, all over 2 times a, and a in this case is negative 3. So we get negative 4 plus or minus 4 squared is 16. Negative 4 times negative 3 is 12, and 12 times 1 is just 12, all over negative 6. So that gives us x equals negative 4 plus or minus 28 all over negative 6. Well, we can break down the square root of 28. It's 4 times 7. So that gives us square root of 4 is 2. We're left with root 7 over negative 6. Now, we can actually divide all of this through, and we can divide everything here by 2. So that's going to give us negative 2 plus or minus root 7 all over negative 3. How do we convert each of these answers to a decimal? How do I convert negative 2 plus root 7 over negative 3 and negative 2 minus root 7 over negative 3 to a decimal? Well, on your calculator, what you do is you do the numerator first. You go negative 2 plus the square root of 7, and hit enter. Then you divide it by negative 3, and we get negative 0.215. You then go negative 2 minus the square root of 7, hit enter, divide it by negative 3, and you get 1.55. So there are those two things as decimals. So basically what we're covering in this lesson is, how do we find x-intercepts when you can't factor? Well, we have to use quadratic formula. And as I said earlier, you can use quadratic formula even if it's factorable.